18, we need to talk about how a function that represents position relates to a velocity function, and how the velocity function relates to acceleration function. Now, we're going to be doing these type of questions all year long because, again, we do derivatives this semester, but when we do integration next semester, we're going to be doing the same thing in the other direction. So, a position equation is usually called S of t, thank you, or X of t, either one. Both of those are very common. I didn't know why they ever called it S of t, so I looked it up a few years ago, and that's for like space, like where you are in space, is where I got the letter. So that's like at time 3 seconds, you plug in 3 for t, where are you at? And you can get a location. But we also have velocity function, which sometimes we call v of t, or what you need to know, it's the derivative of position. So the instantaneous rate of change of position, also known as derivative, ends up giving you velocity. And then, if you take the derivative of velocity, how fast velocity changes at an instant, that tells you something about acceleration. Or you could take the second derivative of position to get acceleration. So taking the derivative of position gives you velocity, taking the derivative of velocity gives you acceleration. That's the part that you need to know. Okay, also, I know this one's a little more intuitive for those of you that do physics and stuff, but we also talk about speed. You need to know the difference between speed and velocity. Velocity can be negative. Like if velocity is positive, it means you're either going up or to the right, but if velocity is negative, it means you're going down or to the left, just depending on the context of the question. But when we talk about speed, we don't care about direction, so speed is always positive. Otherwise, speed and velocity mean the same thing. Okay, so just to work out a couple of real basic examples here, I've got a position function. So t squared minus 4t plus t, it's supposed to give me the position at any given time. So if I want to know the position at, let's just pretend this is 1 second, then I would plug 1 into the position equation, do the arithmetic there, and I know he is at 7 feet, 7 miles. Oh, we actually know. This is in feet. Let's say t is in seconds. Let's add that in the directions. So we can do units here too. So position, he's 7 feet from where he started. Now, if I want to know what is his velocity at 1 second, what we'd have to do is we'd have to know, the calculus you have to know, is that the velocity function comes from taking the derivative of the position function. So bring the power down, lower the power by 1. Bring the power down, lower the power by 1. And the derivative of a constant is 0. Of course, 0 doesn't change anything. And that should kind of make sense, because if you're just adding 10 to the position one time, that doesn't change how the speed that you're going. It just added it initially. So now I've got a velocity function, and if I want to know the velocity at 1 second, I can plug in a 1 into it, and I get -2. Now velocity is very similar to speed, so it's got very similar units. It goes this far per this amount of time. You do need to put the units down, because when we do FRQs, lots and lots and lots of our FRQs talk about position, velocity, and acceleration, and a lot of times the points come from doing the units correctly. Okay, for part C, the speed of the particle at 1 second. Well, speed is just the absolute value of velocity. So the speed at 1 second is going to be the same as the absolute value of the velocity at 1 second. So 2 feet per second. Again, it's just like a car. When I ask you how fast did you drive your car, you would never say negative 55 miles per hour. We're not generally interested in the position or the direction of your car. We just want to know how fast was it going. Okay, and then if I want to know something about the acceleration, if I only had position, I know that I could take the derivative once to get velocity, and then I could take the derivative a second time, do the power rule again, and know that the derivative of a constant is 0 again, and it looks like the acceleration is 2. Now notice there's no t's here, so it doesn't matter what time you're talking about, acceleration is always 2. Now, what kind of units do you think acceleration would have? Very good. Feet per second squared. And it's fine if you don't know these units from a physics class, but again, you do need to pick them up for our class. Positions are like lengths. Feet, miles, inches. Velocity is going to be a distance per time. Feet per second, miles per hour, some distance to some time, and acceleration is always going to be a distance per time squared. So feet per second squared, miles per hour squared, stuff like that. Okay, so to say the same exact things again, but now we're talking about same function, but what if it was at 3 seconds instead? So if you want to know the position at time 3, you're going to plug 3 into the position equation. Do the arithmetic, and you end up with, looks like 7 again. So he was at position 7 feet after 1 second, and then he was back to position 7 at 3 seconds also. Okay, for velocity, again, the only, well, I guess there's 2 calculus parts to this. You have to know the derivative of position gives you velocity, and you have to be able to take that derivative. So I've done this one 3 times already, but if you want to know the velocity at time 3, it just means you're going to plug a 3 into that, and you're going to get 2 what? Very good. Velocity is like speed, so it's a distance per an amount of time. Okay, if you want to know speed, it's just supposed to be the absolute value of velocity. So if it's positive, it's going to stay positive. And then last one, let me ask you guys what you think so I can make sure that you caught what you needed out of here. If this was on your next test and this is all you had and you were trying to find the acceleration at 3 seconds, what would be the first thing you have to do? Say a little bit louder, please. Okay, you take the derivative of this, and the derivative represents what? Okay, and then what would you have to do? Right, know that the derivative of velocity gives you acceleration, and take the derivative correctly again. Notice I'm just doing power rule here. I know power rule, you probably saw power rule for the first time last class, but it'll be intuitive very soon because we just use it so much. And so this is the equation for acceleration. So if I want to know at t equals 3, I try to plug in 3 for t, but there's no place to plug in a t, so the acceleration is always going to be 2. And then this question was feet per second squared. Those of you in physics, have y'all started doing stuff like this yet? Position, velocity, acceleration, that kind of stuff? Yeah, I don't know if he does. I don't know if he teaches you the calculus part behind it. I think he might have like other physics formulas that like are harder to work with, but can still get you the same answer. So I would ask him if you can use derivatives to see if that's still the same. Okay, on to the back. Let's look at a couple other question types that have come up. So question 2 was one we used to put on a test a long time ago, and I just want to kind of talk about a good way to approach this question. And you let's see, you don't know how to do this derivative yet. Okay, we might have to come back to that part. You don't know how to take the derivative of this until we do the next handout, but that's okay. Let's look at this graph. We'll come back to that later, another day. Okay, so I've got a velocity graph down here, and this is very common for your AP exam. In fact, one of your 6 FRQs that you will get on your AP exam is probably going to be either a first derivative graph or a velocity graph like this. So I would like to know, and I didn't explicitly say this, but I would like to know when this thing is moving to the right. So it's going to be moving to the right when the velocity is what? Positive. Not increasing, but positive. So we look at our graph. What part of the graph is positive? Since this is velocity.
0 to 30.
Very good. And what is true about the interval 0 to 30? All of that is
Moving right.
because it is
Positive velocity.
Above 0.
it's above the x-axis, right? Above the x-axis is positive values. So from 0 to 30, and let's go ahead and practice units again, especially since it says here. Let's say time is in whatever, let's do seconds, and velocity could be, let's do actually let's do hours here. This is more familiar to you. Miles per hour, and then this can be in hours. Now, what you need to understand is this could be one part of an FRQ right there. Just knowing that when velocity is positive, that's your justification. This is when it's positive. Your answer and your justification. Very easy justification. It's not like a full sentence. It's not a full definition like we did with continuity. It's just stating that. Okay, so if when velocity is positive is going to the right, when velocity is negative is moving to the left. So when is velocity negative based on this graph? Okay, 30 to
55.
very good. 30 to 55. And I know that it's negative there because it's below the x-axis. Don't fall into the trap of just trying to memorize. Oh, these answers are above the x-axis, those answers are below the x-axis. Don't do it that way because it depends on the graph. It's moving to the right or up when velocity is positive. It's moving to the left or down when velocity is negative. Just depends on the question. And then at rest, that would be where, well, what do you think?
0.
Okay, I heard 0. What else do y'all think?
The x-intercepts.
Okay, very good. So when the velocity is 0, that's when he's not moving. Again, velocity basically means the same thing as speed. So he's not moving at 0 seconds, he's not moving at 30 seconds, and he's not moving at 55 seconds. There's 3 times where his velocity is 0 during those times. So again, this could be the answer of an FRQ, and that can be your justification. We know that because that's when velocity is 0.
It's supposed to be hours.
Oh, hours, sorry, yeah. Hours. And then up here, this should, I should have put units on these as well. This is velocity. Velocity would be, oh, well, it's right here, miles per hour. Okay, the next question, is this the last part of this one? Yeah, so last part of this one, I have told you how to do this one, but this one is hard for people to make the connection because we're connecting a couple things I've said this morning already. I would like you to go back and let's state the acceleration during each one of these intervals. So I'd like to know the acceleration during this time, during this time, during this time, during this time. How in the world am I supposed to know what acceleration is? It's the derivative of what? Okay, acceleration is always the derivative of velocity. And how am I supposed to get derivatives out of this graph? Slope. Very good. Derivative means slope. So we can count rise over run here. And it looks like it's going up 6 to go right 10. Or up 60 to go right 10. So this has a slope slash derivative slash acceleration of 6 miles per hour squared. What would the acceleration be from 10 to 15? Zero. So notice, it's not that it's hard to calculate this, but you have to connect a couple concepts. Derivative means slope. We're just thinking about slope of this line, but also derivative of velocity gives you the acceleration. Okay, for this whole time, he's got a consistent slope. So that means he's got a consistent derivative. And so we could count rise, it's going down 100 to go right, and it's going right 25. So during that time, the acceleration is negative 5 miles per hour squared. And then during this time, rise over run, it's going up 40 to go right 15. Make sure you're careful with these units. So that's like 8. About 8/3 mile per hour squared. So to get the answers to this acceleration part, I really was just counting rise over run. But you need to understand why I was counting rise over run. Derivative of acceleration is how you know something about, derivative of velocity is how you're going to know something about acceleration. Up to the start here. The derivative of velocity is acceleration, or the second derivative of position is acceleration. And you have to know to find those derivatives, they have to come from the slope. Okay, so that should come up a couple times in our work today, but I need to introduce you to just a touch more here. So on 19, honestly, this is probably this handout here is going to be the biggest chunk of our time in this unit as far as practicing and making sure that we can do these correctly. Okay, so unfortunately, these don't work out as nice as limits do. When we talked about properties of limits, I said if it had an add sign in the limit, you could do them separately and then add them. There was a subtract sign, you could do the term separately, take the limit of each term separately, and then subtract them. If it was multiply, do them separately and multiply. If it was divide, do them separately and divide. Derivatives don't work that way. Adding and subtracting works that way. That's why we can do one term at a time. But multiplying, which we call product, and dividing, which we call quotient, you can't just do them individually and then multiply them together, or do them individually and divide them together. We have to have these formulas to do product and quotient of derivatives. So this is the formula for product rule. So all of this is saying is if you want to take the derivative of something times something, they're calling the first something f of x and the second something g of x. To find that answer, you're going to take the derivative of the first part times the second part left alone, plus the derivative of the second part times the first part left alone. You have to do that whole thing. You can't just do them separately and then slap a multiplication symbol in between them. So to show you this in question 1, this is something times something. So I'm going to follow this pattern here. I'm going to take the derivative of the first thing. I'll bring the power down, lower the power by 1, and then I'm going to just move it to the denominator to give it another positive exponent, times the second part left alone, plus, now the derivative of the second part, well, what is the derivative of e to the x? E to the x times the first part left alone, which is square root of x. So technically, this is the derivative. What can be frustrating though is sometimes we're going to have to simplify this. Like they both have an e to the x, so maybe we have to factor it out front. This one's a fraction, so we might have to get a common denominator to write this as one big fraction. It just depends on the question. So that'll be part of our struggles with our book assignment today, but we'll worry about that when we get there. Okay, so for question 2, let's say I want to know the derivative of f of x. Based on look at the formula here, the first part wants me to take the derivative of what?
X cubed.
Okay, and what is the derivative of x cubed?
3x.
Okay, 3x squared. Bring the power down, lower the power by 1. That's the power rule. Times, leave the other part alone, plus, and then just do the opposite. Now I'm going to leave the first part alone, times the derivative of the second part. G, this is what they're calling g. So that would be, bring the power down, lower the power by 1, move it to the other side of the denominator, and the derivative of the constant is 0. So we don't need to write that. So again, technically that's the derivative, but we will have to practice simplifying it some, but not for right now. Right now, all I need you to see is how this is getting pieced together. F, 1 times the derivative, 1 time it's left alone. G, 1 time you take the derivative, 1 time you don't. And you have to do that whole process for when it's the derivative of something times something. Okay. Anything jump out at you about that? Okay, then let me go ahead and show you the other one. So the quotient rule is when you want to take the derivative of something divided by something. And here's its formula. And you do have to memorize this, although I really just memorized the pattern. If we call the top part f of x, the first part of the quotient rule is to take the derivative of the numerator, but the derivative of e to the x is e to the x. Then it says times the denominator left alone. G of x is what they're calling the denominator. So I will leave sine x alone. And we've got a minus sign. Now I want the derivative of the denominator. And what was the derivative of sine? Very good. Be careful that it's not negative cosine, because one became negative, one didn't. Times the numerator left alone, which would be e to the x. And then this all goes over the denominator squared. So if you memorize things like the derivative of e to the x is e to the x, the derivative of sine is cosine, this isn't really that much harder. It's just that you have to know when to use it. That's when you're taking the derivative of something divided by something, and you have to know this format. You have to know this formula to know how to piece those things together. But, okay, on to the next page, or the back of this. I've got a few practice questions to try to pull this together. But first I want to go ahead and tell you what the other 6 trig function derivatives are. So I already told you this one and this one last class. The derivative of sine is cosine, the derivative of cosine is negative sine. So you should be familiar with those two already. You will need to memorize the other 4 eventually. You don't have to do that between now and Monday, but you will have to memorize those. That being said, there is some patterns in here. Do y'all notice anything, like 3 of these have something in common and 3 of the others have something else in common? Can y'all pick up any patterns in this?
All of the codes that are negative.
Okay, so anything you're taking the derivative of anything that starts with C. Derivative of something that starts with C is negative. Derivative of something that starts with C is negative. So that'll help you a little bit. If you're taking the derivative of a trig function that does not start with C, it's positive. And I can show you how to actually derive these someday, but for now, I just need you to see them so you can try these questions. Okay, I would like you to go down here and using what we've talked about on this worksheet, try 4 and 5. Just go ahead and commit yourself to what you think the derivative would be. If you think it's product rule, flip it over and look at the product rule formula. If you think it's quotient rule, flip it over and look at the quotient rule formula. If you think it's a trig identity, look at the top of your page. But I'd like you to fill in those 2 with your best guess, and then we will correct it maybe. Okay, I don't know if that was enough time, but it was enough time for you to see if you went down the right path. So for question 4, the derivative of this part, you don't need to know anything except that it's going to be 3 times whatever the derivative of secant is. So that was on the top of this page. The derivative of secant is, secant x would be secant x tangent x. And again, you'll know that one once you memorize it. And then same idea with this one. This is going to be negative 10 times the derivative of cosine. And the derivative of cosine is what? Negative sine. So that changes that to a plus. So you can do that one as soon as you memorize trig derivatives. But for question 5, what I wanted you to see is that this part, make sure that you're making good habits of using proper notation too. This was g of x, so your derivative was g prime of x. This is y, so this is y prime. Put the prime mark when you move over to derivative. So this part was nice and easy. It's 4 times whatever the derivative of cosecant is. So the derivative of cosecant is negative cosecant x cotangent x. So that one you'll know once you memorize that trig derivative. But I wanted you to see that this, or I wanted you to see if you fell into this trap, the only way to take this derivative is with product rule. You cannot just take the derivative of e to the x, then separately take the derivative of sine, and then just slap a multiply sign in between them. If that was the case, we would not need the product rule. So you should have thought of this as the first term, or e to the x, this as the second term, or g to the x, bless you. And again, you can either memorize the formula or just memorize the pattern. I memorized the pattern. I would take the derivative of the first times the second left alone, plus the derivative of the second with the first left alone. And if you know the derivative of e to the x is e to the x, and you know the derivative of sine is cosine, and once you know the product rule, then all of that makes up the derivative. Okay, any quick questions about number 5? Any of that you don't know where I got? Yeah.
Why did you include the 5?
Well, the 5, if you're multiplying this by 5, it's going to make the rate 5 times bigger. So if there's a constant, you can just pull it out front. So like last time, we saw some like this, and I said you can really think of this one as like just the power rule. Bring the power down, lower the power by 1, right? Or you could say, I'll deal with the 2 later, and then just do the power rule of 2 to the x, but you still get 4 to the x. So that's basically what we're doing. I'm just saying, let's worry about the 5 later. If you didn't, you would have 5s in both of these, and then in theory you could factor your 5 out as a GCF, and it should be the same as mine. So you don't have to pull it out front, it just makes it easier if you do. Those constants, I just pull them out. Other questions about 5? Okay, then you give number 6 a shot. Actually, go ahead and try 6 and 7. And again, feel free to use the 2 formulas on the front page, and feel free to use the trig derivatives at the top of the page. I know you don't have those memorized yet. I just want you to see if you understand how you're supposed to use them. Let me give you just, let's say 2 minutes here, and then we'll go over them, finished or not. Again, obviously I'm not expecting you to be experts, I'm just trying to get you to
put some thought into what you should do so you can see if you're on the right track or not. We're going to get lots of practice from the book assignment. Okay. Finished or not, let's go ahead and talk about what you should have done. And of course, please make corrections mentally and on your worksheet here. But the first part of number 6, this part shouldn't have been too bad. This part could use the, actually before I do derivatives, this part you could just rewrite with exponent rules. So instead of w to the 4th in the denominator, you could think of it as w to the negative 4th in the numerator. So now when I start talking about the derivative, this is just power rule. Bring the power down, lower the power by 1. Negative exponents, you will have to move to the other side of the fraction today. Minus, now what did you do with this stuff? You have to do the product rule. You can't just say this is 2w and this is secant squared w and throw a minus or a multiplication sign in between there. You have to do the whole product rule. It would be nice if it worked that way, it just doesn't. So you had to take the derivative of w squared, which is 2w, times tangent of w left alone, and then plus, now you're going to leave w squared alone and take the derivative of tangent, which is secant squared. All of that makes up the derivative. You guys okay with why I did product rule there and where the pieces of product rule came from? Okay. And then on 7, what did you do? How did you try question 7? Okay, good. It's something divided by something, which is the quotient rule. So you had to look at the formula on the front page. You take the derivative of the numerator. Derivative cosine is negative sine times the denominator left alone minus, now you leave the numerator alone, times the derivative of the denominator. And what is the derivative of the denominator? Very good. The derivative of 3 is 0. The derivative of negative 2 sine t is negative 2 times the derivative of sine t, which is negative 2 cosine t. That's what you said, right? Okay. And then the part that sometimes students forget, because there's a lot going on here, but it's all over the regular denominator squared. All of that is the derivative of that equation. So other than memorizing the formula, it's not that it's harder, it's still memorizing the derivative of sine, memorizing the derivative of cosine, sometimes power rule, but it looks pretty intimidating, but we just have to follow that pattern.
What's the bottom squared?
That's just how the formula works. If you look right here. All over, if you call the denominator g of x, it's all over g of x squared.
Would you ever multiply that out or just leave it?
Yeah, unfortunately, we will simplify some of this stuff. I'm just worried, we'll worry about that when we get to the book assignment. Because on the book assignment, I did include, now like last time, please don't write on these book questions. I'm going to use these for other classes. The back of it does have the odd answers, and we will make sure that our work matches up with the odd answers, so that's where we'll get practice on the simplifying. So, yeah.
Does it matter what order you write the finished product in?
Okay, she asked, does it matter what order you do it in? And it depends. If you're doing product rule, it doesn't matter because addition is called commutative. 5 plus 3 is the same thing as 3 plus 5. So if you want to do this first or this first, it doesn't matter. But in quotient rule, it does matter because this is subtract. 5 minus 3 is not the same thing as 3 minus 5. So it does matter for the quotient rule. Good question. Okay, let's shift over to, you will need a blank piece of paper, and we are going to start these off together. I realize this takes a lot of hand holding here at first, but you will need a blank piece of paper, and I'll just jot down the first few questions on the board. Before I put the whole assignment back up. Okay, the first questions are number 3, number 5, number 7, and number 9. I know you have this in front of you, but I still want to write it down on my page. You should definitely keep your notes out, though. Okay, and they'd like us to take those derivatives. So they even tell you in the beginning, question 3 and 5, they say use product rule because you've got something times something. And in 7 and 9, they ask you to use quotient rule because there's something divided by something. So I will give you a few minutes head start. You can check the answers. These are all odd, so if you flip to the back, I did include the answers in the back. So you can see what the answer to number 3 is. So do the product rule, see if you can simplify it, and if your answer looks like that, then move on. And if it doesn't look like that, you'll need to pay attention when I go over it. And obviously, if you did get it right, you can move on to the next question. So I will go over as many of these as we have time for, but also those of you that feel like you get the hang of it after a little bit, you also have it in front of you to go. Now, you will need some space for some of these questions. So if you're the type of person that tries to cram all your work in to the top half of your page, that's going to cause problems for you. And if you really get stuck on one of these, just do what you can, and then move on and start the next question, and then just be ready to pay attention when I go over it, please. It will get easier, but certainly a skill that takes a lot of practice. I'd probably change it back to the square root for my final answer, but yeah, don't worry about what your answer looks like until you check your answers in the back. If your answer doesn't look right, if it doesn't look as the same as the answer in the back of the book that I have printed out for you, first, make sure that you feel confident about the derivative work. And second is probably the simplifying, which again is going to be a big challenge in this section, which is why there's going to be so much practice. have one homework page here that didn't have a name on it, so I didn't know who to give credit to. If you didn't get yours back today, but you did it, and you gave me a hard copy, it'll be here in the third period box. But I don't know what's yours to give to you. Okay, so I am going to go over the first question now, just question 3. So again, if you did that, you got the answer to look the same as in the back, and you feel okay with that, tune me out and just keep working. Eventually that'll pay off for you. But if you got stuck on number 3, you either didn't do your derivative right, or you don't know how to simplify your answer to make it look like theirs, then you need to follow along with me. Okay, so I can pretty much instantly tell you that this is going to be product rule, because I've got something, I want the derivative of something times something. So I know the product rule says take the derivative of one of them, bring the power down, lower the power by 1, and leave the other one alone, plus, and then you do it in the opposite way. Now you're going to take the derivative of this one, which would be negative 2t times the first one left alone. You guys okay with that part? So I did power rule 2 times, and otherwise I just did what the formula said. Now here's where, I think I mentioned this maybe last week sometime, this is where it's kind of frustrating. Sometimes this is enough. If this was a free response question and all it said was find the derivative, technically this is the derivative and you're welcome to quit. The frustrating part is, if this shows up as a multiple choice question, which it does, you probably have to simplify this and make it, simplify it some until you can make it look like their correct answer. So when I look in the back, my answer does not look like theirs. Their answer says 1 minus 5t squared all over 2 square root of t. So how do you think they went from these two terms to just having one big term? How can I force these two things together?
The same denominator.
Very good. Get a common denominator. So think of this as like, this is like 1 over, what was it, 2 square root of t. And this is like over 1. So I can force these two things together with common denominators. Now, in your head you should say, do I always have to do this? No, you don't always have to do this. It depends on how much simplification they did to get the answer. So we are going to practice until it looks the same as the back of the book, because that's what you would need to do for multiple choice. So this has a denominator of 2 square root of t. So this guy needs a denominator of 2 square root of t. You can't multiply the bottom by 2 square root of t without multiplying the top. So if we do that, now they have a common denominator of 2 square roots of t. Up here, I've got 1 times this stuff. Over here, if I multiply this mess of stuff, I've got a minus 2 times 2, a t times the square root of t times the square root of t. What did those come out to be? Okay, very good, t squared. And then I'm left with 1 minus t squared minus 4t squared, so that's minus 5t squared. And now it looks like that. So now we can quit. So I didn't give you that hint. I didn't expect you to think of that. But sometimes after the derivative, to simplify, you have to get a common denominator. Sometimes. So go ahead and finish that one. And I'll give you, again, you should try to be a few questions ahead of me here, but I will reset our timer, give you a minute or two, and then I would like to go over the next question. Basically, you're just doing the odds. I'll put up the full assignment before class is over, but You should be doing every odd question at least to question 35, and then it skips around a little bit. Okay, so question 5, second question. This is what they got for an answer in the back. So again, if you got that, you don't need to listen to me go over it. I'm just going to go over it for anybody that got stuck. Now, technically they gave you a hint in the directions to use the product rule, but you need to understand why you're doing the product rule. Because you want a derivative, and it's something times something else. So, the pattern, which as you do these questions, try to lean on your notes less and less. Try to learn the pattern as you do them. But it says take the derivative of the first one times the second one left alone. Just that the derivative of e to the x is e to the x. Plus, now leave the first one alone times the derivative of the second one. And the derivative of cosine x would be negative sine x. And again, sometimes that's enough, but I have to make you practice the simplifying so that you can identify it for multiple choice. So what does it look like they did to go from here to the answer? Yeah, so they just realized there was a GCF, and so they chose to factor out the GCF. That's all the simplifying that they chose to do there. Okay, anything that jumps out to anybody about question 5 you'd like to ask? Okay, give you a few more minutes then before I go over question 7. So keep on going.
Yeah.
Which questions are we doing?
All the odds, just keep doing the odd questions till I think 35. So I'll put up the full assignment to write down later. But we're not going to get anywhere near finished with this assignment in class. So. Okay, it's been 2 minutes. So number 7, if you did not end up with this as an answer, either you got stuck or you can figure out how to simplify it, then you need to follow along with me so I can help you get unstuck. Whatever caused you issues on this question is just going to keep causing the same issues on next questions. So don't be dismissive here. Okay, so same thing. The directions gave you a hint to use the quotient rule, but as time goes on, you need to understand why you're using the quotient rule. Because I'm taking the derivative of something x divided by something else. Quotient just means, quotient's one of those words that means divide. So to take the derivative, you just have to follow the pattern that the quotient rule says. It says take the derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone, and don't forget it's all over the denominator squared. Don't be lazy and not write the denominator, because that will be a bad habit that messes you up. Now again, sometimes that's enough, but I don't want you to be able to do the calculus and not realize this is the correct answer on the test. So the simplifying in this question, if you distribute here, you've got an x squared plus 1 minus 2x squared over this stuff. So it looks like the only thing that they did was they combined like terms. Minus 2x squared plus 1x squared makes a negative x squared. So the simplifying on that one was pretty easy. So not hard derivatives. The derivative of x is just 1. The derivative of x squared plus 1 is just 2x. But practicing putting it in this quotient rule format and understanding why you have to do quotient rule is what you need to get out of that question. Okay, if you still have a question about 7, go ahead and ask. Otherwise, keep on going, please. I do realize some of these questions are a little bit longer, and I've taken that into consideration on our timers. So. Also, just a heads up, at the end of class, what I'll ask you to do is a few more of these for homework past where we get as a group. So, again, those of you that this is clicking with and you're getting the answers in the back, go ahead and keep moving on at your own pace. So you end up having less homework than everybody else. You're still going to have to do all of it eventually. So. Time's up for question 9. I suspect 9 is one that many of you need help simplifying. So again, this one is quotient rule. This is just as much the most important part here, knowing why to use it. So quotient rule says take the derivative of the numerator. Now if you need to do that over to the side, that's fine. Bring the power down, lower the power by 1, and then you probably want to move this to the denominator to make it have a positive exponent. So the derivative square root of x is 1 over 2 square root of x times the denominator left alone minus the derivative of the denominator, which would be 3x squared, times the numerator left alone, all over the denominator squared. Now again, technically this is the derivative, and occasionally that's good enough, but oftentimes it's a multiple choice, and they're going to do some simplifying to make it look like this, and these two are not obviously the same. So what stands out to you about this mess of stuff? You cannot cancel these out because this is part of a term, so you can't cancel out terms, you can only cancel out factors. Exactly. There is a complex fraction. You have a small fraction within a bigger fraction. Good news is we've already talked about how to deal with complex fractions this year. It's the same way we dealt with them with limits. I would love to multiply this term by 2 square root of x so that it cancels that out. But I can't do that without multiplying every term by 2 square root of x. So notice this is why the denominator has a 2 square root of x in it. Okay, over here, carefully multiply this mess together. I've got a 3 times a 2, which would be 6. A square root of x times a square root of x would just be what? X times this x squared gives me x cubed. And then finally, 1x cubed minus 6x cubes, you could combine to be minus 5x cubes. So, am I saying that you have to simplify complex fractions often? No. But if you did the product or quotient rule and you've got fractions within a fraction, you probably want to multiply every term by that smaller denominator, just like we did with limits. Then at least it's not in complex fraction form, and then really all I did was combine like terms to get to the answer. Okay, if you see something you'd like to ask about 9, then go ahead and tell me what it is. Otherwise, pick back up wherever you left off. 11 looks a little bit nicer. Again, they just vary. Some questions are really messy like this one. Some questions are a lot more straightforward. But it just takes a lot of practice before we all feel confident. Just stick with it. It'll get easier the more you do. You know how to do this one?
Which one?
Number 11.
I don't know, we're not there yet.
What are you on?
I just got done.
Oh.
Actually, that looks easy.
Okay. That's what I thought.
Yeah,
but
it's cosine negative sine x over e x.
it's not. But it's minus, not. Okay, for question 11, if you did not get that in the time that I gave to you, okay, direction still gave me a hint to use quotient rule. I want the derivative of something divided by something. Hopefully you're needing to look at the quotient rule a little bit less. It's derivative of the top times the bottom left alone minus the derivative of the bottom times the top left alone, all over the denominator squared. And then it looks like you could do two things to simplify it from where we're at to what we need it to be. Both of these terms had an e to the x, so you could factor in e to the x out front, GCF. And then e to the x squared means e to the x times e to the x. So this can cancel out that, and then you come out to that answer. So for 11, you have to know the derivative of e to the x is e to the x. You have to know the derivative of sine is cosine. You have to know the quotient rule to know how I piece that together. And then simplifying. GCF and undo times with divide. Okay, same thing. If you see a question about 11, go ahead and let me know. Otherwise, let's look at one more together. I'll give you a little bit more time here. So I'd still like you to try 13. Look at 13 together. And then I actually want to make one more connection for you on question 3. But we'll find a stopping place. And I'll pick a number I'd like you to get to by next class. Okay, so 13 had the answer written in a couple different ways, so I'll talk about that in a second. But there's also two things they want you to find here. They want you to find the derivative and the derivative at 0. So that just means plug 0 into whatever you got the derivative of. So these are the two answers they come up with. So I look at this and notice once we got to question 13, it's no longer giving me a hint in the directions. It's not saying use product rule. It's not saying use quotient rule. It's figure out what you need to use. So I want the derivative of something times something. That's how I know it's product rule. So I'm going to take the derivative of the first part, 3x squared plus 4. Just did power rule twice. Times the second part left alone. Plus, and then do it in the other order. Now I'm going to take the derivative of the second part, which would be 6x plus 2, times the first part left alone. And then there's the derivative. And it looks like the only thing that they did is they put this term first and this term second. And again, that's fine with addition. Addition is called commutative, meaning it doesn't matter what order you add in. So I guess if you really needed to put this stuff first plus this stuff second, then it'll look exactly like that. This question did remind me of one other thing I wanted to say to you though. But then the second part of the question was what's the derivative at 0? So basically if I plug 0 in for all of these x's, I get 0 times 2 plus negative 5 times 4. So the derivative at 0 was negative 20. So even though that's a long and complicated looking derivative, plugging in 0 was pretty easy to evaluate. Okay, you guys okay with where my derivative came from and my derivative at 0? You okay with where both those came from? Okay, Luke, you need to take your headphones off. Okay, the one other thing I wanted to point out to you, just very quickly, I didn't do this in question 3, but I just want you to know that this is a thing. If on question 3, let's say I gave this to you on the test, it's probably not going to say, well, if it's multiple choice, it doesn't matter anyway. You could do this doing the product rule, something times something. But generally speaking, just like I've been saying last class, if there's some algebra, arithmetic that you can do first, you probably should do that first. So honestly, this question 3, if I was working this, I probably would have distributed this. Multiplying things with the same base, you add the exponent. And then the reason I like to do that is because then this is an easier derivative for me to do, and this is an easier derivative for me to do, and it ends up being equivalent. So sometimes distributing makes sense, and then the calculus. And the reason why this question made me think of that was, in theory, in question 13, if you want to distribute all of this and get like 6 terms, you could do the power rule 6 times instead of doing one big product rule, and that's fine as well. So when you check the answer in the back, they had 2 answers for this part. The other answer would have been if you had multiplied all this together first and then did the derivative. Okay, you don't need to copy down the full assignment, I guess, yet, but what I'm going to ask you to do for homework is I want you to do 5 more of these. So we got to question 13, so you need to do at least 15, 17, 19, 21, and 23. At least through question 23, so at least jot those down at the top of your page. All of those are worked out on the website, so if there's any of those 5 that you get stuck on, you need to watch the video online before you come to class so that you are up to speed and at the same place as everybody else. And we will worry about working on the assignment more next time. I'm only asking you to do 5 more for now.
I would, I guess, as always is the case, if this is one of the hardest things you've ever done and you're really struggling, of course, it's not a bad idea to do more than 5. That would help you out, because the sooner you get practice under your belt, the sooner you're going to feel better about these things. And I do have every single one of these worked out on the website, so. But at least do 5 for me, please. And then we will look at more of those together next time. Okay, and then I saved a couple minutes, of course, for our daily puzzle. I need a better system so I can keep up with which ones you guys have done, but let me see if I can find it real quick. Okay, y'all saw the logic puzzle, yes?
Yes. Yes.
We talked about poison rats. We did this one.
Yeah.
You did the lock. Not the lock. Okay, there's today's puzzle then.
Mr. Townsend, so when I was doing 17, the other book assignment, I was on your math page and I couldn't find the actual questions. So are they posted for this one?
For this one, no, not yet. I just need to copy and paste them over there.
Okay, thank you.
I do need those book pages back, by the way. I'll just put the tray by the front door so you can just put them there. Unless you just want to throw it out and you can buy. Again, you don't get to keep the book pages. I can't print out this for every single student, so these are just to use in class. So make sure you give me those before you go.
Oh, wait, sorry. It would be better if it was a longer comedy.
I don't understand how they did do this after practice, because I don't understand why they couldn't do a list after practice.
I know, it makes me mad too,
Because I could have
because
slipped in.
I got school after.
I don't have to be here until it's
Yeah, it sucks with
you had to wake up at 7.
Go back home, like I know Reed, B-Day, like any school, and you have to come here and get more.
Yeah, and I can't like go back to sleep.
It's annoying, I don't know. I mean, I know how to do it, but.
Even not.
And I can't, I don't have a sheet, and I leave.
My sister
I don't care. I could have lived my life not knowing about that, I was just happy. And
Anybody figure it out yet?
I think that's right.